All right, in video 1 of the series, we learned about how the three angles of a triangle relate. And that is all three have to add up together to get 180 degrees. Today we'll talk about the three sides of a triangle and how they relate. So to begin with, let me give you an imaginary triangle here. This triangle is going to have side lengths of 3 inches and 4 inches and 5 inches. Okay, so if I drew that, I could actually draw a triangle that looks like that. It would look something like this. All right, I could draw this one will be 4 inches, so it'll go from here to here. That's 4 inches. And then I could draw one going this way. It's 3 inches. That's 3 inches. And then hopefully this last one's going to be 5 inches, which I believe it will be, because I planned this out earlier. All right, there it is, 5 inches. And actually this happens to be a nice right triangle, just for those who are interested. But in fact, if I have these lengths, I can indeed make a triangle with side length 3 inches, 4 inches, and 5 inches. That's totally possible. Now, let's imagine that I doubled one of these. I doubled that 5 to be a 10. Actually, hold on. Let me ask this one. Is it possible for me to give any three numbers, any three lengths of sides, and for those to connect to make a triangle? Well, let me give you an example that's really pretty obvious to answer from you know. What if I gave you the side lengths are 1 inch, 1 inch, and 1,000 inches? Okay? You're going to end up with this one really, really, really long side. I mean, it's going to be as long as this, I don't know, what's 1,000 inches? Along my classroom. And then you have these little tiny 1-inch things sticking up at either end. One over here, and one over here on that end, right? There is no way that those little tiny 1-inch sides are going to be able to touch each other. They're going to be able to reach. So they won't make a triangle. In order for it to be a triangle, they would have to come up here at a point, right? But they can't. They're too short. Or another way of thinking about it is, this one's too long, right? So we got to make sure that when we're given three length sides, or three side lengths, that one of them is not longer. It's not so long that the other two can't meet, that the other two can't touch. Okay, so that's one way of thinking about it. The long side can't be so long that the other two short sides can't reach. Right? They got to be able to reach each other. So let's think about what that means. What if I have? What if I change this a little bit? What if I make a 2-inch side? I'll make this my long side. Right? This is my long side. It's 2 inches long. All right. Now, could I make, if I have my long side is 2 inches, I can't have my other sides be too short. So could I make them both 1 inch? Could I have 1 inch coming off of this and 1 inch coming off of this? Let me just draw it up, straight up, sticking way up like this. There's 1 inch. Okay, clearly I can't draw it like that because they didn't reach. But what if I could somehow get this guy to come down a little bit more, and bring this guy down a little bit more? Could they reach? If I lower them down, they become closer, right? If I lower them down, would they reach? Remember, this one measures 1 inch, and this one measures 1. So actually, what would happen is if I swung this left one, if I swung him down, he would come down, and he would touch exactly in the middle, right? Because this was 1. If he swung down, this would still be 1 inch, and it would go halfway across. And this guy would also swing down, and he would come exactly to the middle. So I would end up with this line that's 2 inches long, with another line that's 1 inch here, another line was 1 inch here, but it wouldn't be a triangle. It would just be a line, right? So they can't be, it couldn't be 1 plus 1 and 2, right? Because they add up together. But if I made this one, say, if I made it just a teeny tiny bit longer than 1, there's 1. I made it a tiny bit longer than 1, then when I swing it down, it would catch, right? It would catch right, it wouldn't be very tall, but it would catch, and it would, here's a 1 inch, it would catch this one right here. And it would make a triangle, okay? If I just make that side or that side, if I just make one of those sides a little tiny bit longer, so that they don't add up to 2, but that they're actually a little bit bigger than 2, then it would make a triangle. So this idea that your two short sides have to reach each other, they have to add up to be more than your long side, That is what we call the triangle inequality theorem. We call it inequality theorem because it won't work that they equal the long side, right? It won't work that when I add these two sides up, they equal the long side. That won't make a triangle. It has to be unequal. It has to be larger than the third side. So we call it inequality theorem. So the triangle inequality theorem, this just tells us what kinds of side lengths we can have for a triangle. Oops, figure. All right, in this case it means if you add the two short sides, I'm going to abbreviate those. I'm going to say, let's say the short side number 1, if you take the short side, the first short side of a triangle, and you add the second short side of a triangle, your answer has to be bigger than what's called the long side of a triangle. Okay? Does that make sense? So the short sides added together have to be bigger than the long side. And that's how I think of it. They write it differently in different textbooks, but that's how I always think of the inequality theorem for triangles. The short sides added together have to be bigger than the long side, and then it can be a triangle. So if I give you, lots of times the STAR will give you different questions. Could you have a triangle with these lengths? So could you have a triangle with lengths 3, 7, and 11? Okay, so all you have to do is find your 3 short sides, add them together. 3 plus 7 is 10. Is 10 bigger than 11? Nope. So could this be a triangle? Nope. Get another one here. What if I have a triangle with sides 5, 12, and 13? Could that be a triangle? Again, I find my 2 short sides, add them together, 5 plus 12. Is that bigger than your third side? Yes. So that could be a triangle. See how that works? If they add up to be exactly, what if I have 4, 10, and 14? Add your 2 small sides. Is that bigger than your third side? Nope. Equal to doesn't count. It has to be bigger than. That's not going to be a triangle. Excuse me. The other thing I will mention is you can do this as well. Sometimes questions will be a little bit more complicated than that. They'll say, if I give you 2 sides, I tell you that 2 sides of a triangle are 8 inches and 11 inches. Then what could the third side be? What could the third side be? So here's how we do this. We think, okay, well, there's 2 possibilities. Either I'm given the 2 short sides right here, or I'm given the long sides, and I'm looking for a shorter side. So let's take the first one first. Let's say that these are the short sides, and that my longer side is going to be longer than 8 and longer than 11. How big would that third side be? Well, remember, when I want to find the triangle inequality theorem, I add the 2 short sides together, and that has to be bigger than the long side. So if I'm saying that these are my short sides, let's write that out. Short side plus short side has to be bigger than long side. 8 plus 11 is 19. Right? So whatever my long side is, it has to be less than 19. 19 has to be bigger than my long side. So my longest side could be, actually I'll just say it has to be less than 19. Right? So I do it on a number line. Open circle, shading to the left at 19. Right? There's 20. There's 18. There's 17. Excuse me. Okay, well, what if these aren't the short sides? What if these are the long sides? Okay, well, which one's my long side, 8 or 11? Well, it can't be 8, because 11 is longer than 8, so 11 is going to be my long side. So now let's let that be the long side, and my missing one's a short side. So now I'm going to say, I don't know what my short side is, but I know my other short side is 8, and my long side is 11. So now what could that short side be? Well, if I subtract 8 from both sides. I get my short side has to be bigger than 3. My short side, whatever it is, has to be bigger than 3. Okay? Alright. If I graph that on a number line, I have my number line at 0, 1, 2, 3. Boy, I can't write. Boy, I tell you. We have open circle pointing to the right, bigger than 3. So guess what? I can combine these two inequalities. I can combine my two graphs and combine my two inequalities and put them together. So I would have a number line going from 3, open circle, all the way up to open circle 19. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. And it would be all the numbers between 3 and 19. That's how big my third side could be. It could be any number between 3 and 19, but not 3 and not 19. I could write that this way. 3 has to be less than what the number is. Let's call it x, which has to be less than 19. All right? So I can combine my inequalities and combine my graphs of inequalities into one picture and one inequality by writing that like this. All right? So that's the triangle inequality theorem. Two sides, the two short sides have to add up to be more than the long side.